What is set? Actually, set is a collection of well defined objects. What is set? A set is a well defined collection of objects. What is mean by well defined? Example, here is a set A. In that set, some elements are there. What are those some element? Interesting books in library. Set of all interesting books in a library. Is it set? No, it is not a set. Why? Because this collection is not well defined. Since interesting is a reflective term, a book which is interesting for one person may not be interesting for another. So that's why it is not well defined. What is well defined? For example, another set B is there. B set a set of all vowels in English alphabets. English alphabets. This is well defined. Why? Because whoever in the world, everyone set A, E, I, O, U only. So this is well defined set. That is the difference between well defined and not defined. First set is not well defined. Second set is well defined. So B is the correct example for set. Now second one, elements of a set. Elements means in the previous set A, E, I, O, U. These are the elements in the set. So the objects which belong to a set, the object which belongs to a set are called its elements. Here A, E, I, O, U are the elements of the sets. So same previous example A, E, I, O, U. Here elements are A, E, I, O, U. Now next, number of elements. Number of elements in set B. So have we generally number of elements in set B we will denote like this. How many elements are there? 5 elements. So this is the elements, number of elements notation. Number of elements in set B is equals to 5. Next important term is belongs to. This is a belongs to symbol. Belongs to symbol. What is this? Here element A in the previous set, B is equals A, E, I, O, U. Is that A is there in the B? If it is there, so we need to mention like this: A belongs to set B. Is there K in that set B? K is not there, so that's why this is not belongs to. So belongs to and not belongs to symbol, just see, draw the symbol and cut it. Not belongs to. So K not belongs to set B. K not belongs to set B. So E also belongs to set B. I also belongs to set B. O also belongs to set B. U also belongs to set B. This is a belongs to symbol. Now representation of a set. how you will represent the set. Same in the previous problem, just we wrote b is a set. In that b set some elements are there, we don't know those elements, that's why we are taking x. Then what is that x? X is, what is x? X is all ovals. X is a oval, or x is all ovals, or x is a oval. X is a oval in English alphabet. X is a oval in English alphabet. So what will comes in this set? B is equals to same A, E, I, O, U. So same set we are expressing in two ways. So what is the first way and second way? Here we are writing the elements, so directly we are mentioning the elements. So this elements writing method is called listing method or roster method. So here this is called listing or roster. And the above one is called set builder or rule method. In listing method directly we are writing elements. For example, another C is there. Here C is a set. In that set some elements are there: 1 2 3 4 5 6 7 8 9 10. It is a listing or a roster method. Some elements he gave. What are those elements? These elements if you write in the set builder method, so same C is a set. In that set some x elements are there. What are those x elements? X is a natural number. X is a natural number. So x is a natural number means uncountable natural numbers will come. But here how many natural numbers we took? Only 10. So x is a natural number. Here the condition less than 11 or first 10 natural numbers. You can take the x value, less than or equal to 10. X value less than or equal to 10. So less than means 1 2 3 4 5 6 7 8 9. Equal means 10. So this is a set builder form. First one roster form or listing form. Second one set builder form. Next types of sets. Here some types of sets given: finite set, infinite set, singleton set, empty set, non-empty set, equal set, and equivalent set. What is the difference between these sets? Finite set, the elements which are countable in a set, those sets are called finite set. Like prime numbers 1 to 1000 countable, so such kind of sets are finite set. Next infinite set, all the natural numbers are uncountable. That's why infinite set. Next singleton set, the set which is having only one element. For example, natural satellites to the earth. How many natural satellites? Only one, that's why singleton. Empty set, the set which is not having no any elements is called empty set. For example, number of weekdays starting with letter A. So no weekday starting with letter A. Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. So all the days starting with some different letters. No day is starting with letter A. That's why that set empty set. Next non-empty set. So this finite set, infinite set, single set comes under non-empty set, the set which is having at least one element, that is non-empty set. Now what is mean by equal set? If you compare two sets, number of elements and the elements same, such kind of sets are called equal sets. Next, equivalent sets. Equivalent sets means two sets having equal number of elements. There are equal number of elements only. Elements are not equal. Different elements, but number of elements are same. Such kind of sets are called equivalent sets. Now, one problem here. If G is a set, one set is there. In that set, some elements are there. What are those elements? Those X elements are here. X is a 2-digit. X is a 2-digit multiple of 7. So X is a 2-digit multiple of 7. So write down the 2-digit 7 multiples: 14, 21, 28, 35, 42, 49, 56, 63, 70, 77, 84, 91, 98. These are the 7 multiples, 2-digit 7 multiples. Now my question is that 28 belongs to G? Is that belongs to G? Yes, it is belongs to G. Now second one, is that 7, 14, 28, 56, are they belongs to G? 14 belongs, 28, 56 belongs to G, but 7 not belongs to G. So that's why this is not true. We can write this statement false. C1, is that 91 not belongs to G? 91 belongs to G. So this is wrong. 91 not belongs to G. We can write it is no. 91 belongs to G. Next, D1, we can write as instead of yes and no, we can write true or false. So those 35 and 70 belongs to G. Yes, 35 belongs to G and 70 also belongs to G. Yes, we can write yes, they are belongs. Now E1, here 42, 49, 65, are they belongs to G? 42 and 49 belongs, but 65 not belongs. 65 not belongs. Now here I am going to write some sets, whether they are sets or not. Now first one, all intelligent students of your class. It is not well defined. Why? Because in my point of view, some of the students are intelligent, or in some others point of some of the students are intelligent. So that's why this is not a set. This is not a set. Now second one is all capital cities of the states of India. It is well defined. So whoever writes, everybody answer is same. That's why this is S. Now all four-sided polygon. Yes, this one also set. Why? Because everybody answer is same. Quadrilaterals, four-sided polygons, quadrilaterals, square, rectangle, rhombus, parallelogram, trapezium, so and so. So everybody answer same. This is well defined. Next, D1, all multiples of 11. All multiples of 11. This one also well defined. Multiples of 11, 11, 22, 33, 44, 55, 66. That is also well defined. Yes. Next, E1, the collection of interesting books, the collection of interesting books in a library. This is not well defined. Why? Because different person tastes are different. So everybody interesting book is not same. So that's why this is not well defined. So we can say it is no. Now same, all popular soft drinks, all popular soft drinks. This one also not well defined. Why? Because so we are not able to judge with these only popular soft drinks. So that one also not proper set. Next, all letters of the English alphabets. Yes, it is well defined. Why? Because everybody's answer same. Next, all white colored, all white colored flowers. So this one also not well defined. Why? Because at different times the white color flower visible to us in different colors. So this one also we can write not well defined. Next, fractions between 1 and 2. So fraction between 1 and 2. This one between 1 and 2 infinite fractions are there. So this one also set only, but this set is infinite numbers will come. Last one, 5 months of a year. 5 months of a year. This one also not well defined. Why? Because which 5 months he not mentioned. So that's why this is not a well defined. Okay, next, here some sets are there. A is a set, multiple of 2, 4, 6, multiples of 2. B is another set, that is multiple of 3. Now first one is that A, is that 22 belongs to A or not belongs to A? Belongs to A. Why? Because 2 11s are. Next, B1, is that 24 belongs to A and B? Yes. Why? Because in 2 table 2 12s are, in 3 table 3 8s are. So 24 belongs to A and B also. Now C1, is that 26 belongs to B? No, that is not belongs to B. In 20 in 3 table, 26 is not a multiple of 3. Now is that 49 belongs to A and B? No, it is not belongs to A and B. 49 that is not belongs to A and B. Next, even 9, 10, 12, is that belongs to B? No, 9 and 12 belongs to B, but 10 is not belongs to B, not belongs. Next, 27, 45, 63, is that belongs to which one? 27, 3 9s are 27, 3 15s are 45, 3 21s are 63. So these all are belongs to set B. Next, G1, 36, 48 and 72. 36 will come in 2 table and 3 table. 48 also will come in 2 table and 3 table. 72 also will come in 2 table and 3 table. That's why these 3 numbers belongs to A and B. Last H1, so dash belongs to A, not belongs to A and B. So we can take any numbers. 1 not belongs to 2 multiples and 3 multiples. 3 all next to 5. 5 not belongs to 1 multiples and 3 multiples. 7 also not belongs to 2 multiples and 3. Here x is a prime number less than 20. This one set builder form he gave. Set builder form he gave. X is a prime number less than 20. So write down the prime numbers which are less than 20. 2, 3, 5, 7, 11, 13, 17, 19. This is least or listing or roster method. This method name is roster method. This method name is roster method. Next, B1 months of a year with 31 days. So how many months starting with that? How many months having 31 days? January, March, May, July, August, October, December. So total 1, 2, 3, 4, 5, 6, 7 months. March, May, January, March, May, July, August, October, December. These 7 months having 31 days. Next, another method. Represent the following sets in set builder form. For example, he only gave September, direct names he is giving September, April, June and November. He gave a roster form of the set. Now he is asking convert this one into set builder form. Set builder form. Set builder form. What is the special quality between these month names? So simply months of a year with 30 days, or here A is a set, this set having some X elements. What is X? X is a month name of a year with 30 days. This is the set builder official form. A is a set. In that set some X elements are there. So those X elements, what are those X elements? That X is a month name. Which type of month name? Which is having 30 days. So that is the form. Next, another example. B is another set. Here B is another set. In that B, 24, 32, 40, 48, 56, 64. So what is the special quality between these numbers? These all are multiple. First, these all are even numbers. These all are two multiples. So is there any special quality? Again, these all are multiples of 8. So here B is a set. That B set having some X elements. X, what is that X? X is a multiple of X is a multiple of 8. So multiple of 8 means you will get infinite, but this is between the value of X between 20 and 70. The value of X more than 20, less than 70. This is the condition. Now here I'm expressing some sets. So which type of set is that? First, A1. A1, A is a set. What are those elements in that A set? X is an even number not divisible by 2. So this is empty set. Why? Because there is no even number which is not divisible by 2. All the even numbers are divisible by 2. So this is empty set. What is the symbol of empty set? This is the symbol of empty set. Greek word. This is the Greek word. This one we call it by pi. Pi is the symbol of empty set. Next, second one, x is a element. That x is a day after, that is a day of the week after Sunday and before Monday. So there is no day after Sunday and before Monday. Between Sunday and Monday there is no other days. So this set also empty set. We call it as pi or empty set. Next, C is a set. In that set, C is a set. In that set, some X elements are there. What is that X? X is a month of the year starting with the letter S. So which month starting with letter S? 1 month is there, that is September. So how many elements are here? Number of elements in this set. If it is set C, number of elements in this set is equals to 1. So which type of set it is? Singleton set. Single element is there. That's why the set name is singleton set. Single element is there. That's why the set name is singleton set. Next, D set. X is the point S. The point S of intersection of two line segments. If two line segments intersects, how many intersecting points will be there? Only one point. So that one point is S. They are intersecting at point S. So this one also singleton set. This set also singleton set. Next, even set of number of seconds in a year. So it is looking big, but countable only. How? Number of seconds in a minute, 60 seconds in 1 hour, 60 into 60, 3600 seconds. Next, in a day, 1 day, 3600 into 24, 86,400 seconds. 1 day, 86,400 seconds. And I'm taking normal year, 365 days. So for 365 days, 86,400 into 365. So in a second, how many seconds are there? 3 crores 15 lakhs 36,000 seconds. So this one also countable only. This one not infinite set, finite set. So which type of set? So how many elements are there? 3 crores 15 lakhs 36,000. So this one also finite set only, not infinite set. F1, x is an even multiple of 11. How many even multiples are there for 11? 11 2s are 22, 4s are 44, 6 are 66, 8s are 88, 10s are 110, dash 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 dash. How many? Infinite. Here uncountable 11 multiples are there. That's why this is infinite set. This is infinite set. Uncountable 11 even multiples are there. So, set of perfect square numbers between 5 and 9. So he is asking between 5 and 9 perfect square numbers. 9 is a square number but he is asking between 5 and 9. So there is no square numbers between 5 and 9. This one also empty set denoted by pi. Yeah, H1 interesting one. Set of numbers which are neither prime nor composite. How many numbers are there which are not prime numbers, not composite numbers? Only one. One is not a prime number and a composite number. That's why this is non-empty set. It is called finite set or singleton set. One element only there. That's why singleton set. This is singleton set. Next one, set of multiples of 12 between 50 and 60. So 12 multiples, 12 4s are 48, 12 5s are 60. So there is no multiple of 12 between 50 and 60. So this one empty set. So denoted by pi. Between 50 and 60, 12 4s are 48, 12 5s are 60 only. So he is asking between, that's why 50 and 60 not will comes under between 50 and 60. Last one, set of stars in the solar system. Normally number of stars means everybody thinks uncountable infinite set, but here is not asking set of stars in the sky, just is asking set of stars in the solar system. In our solar system, one and only star, that is sun. So how many elements? Only one element. Number of elements, it is E set. In that set only one element, that is sun. So that's why the set name is called singleton set. Single element only there, that's why it is singleton set. Now two sets given. Before, in the before section, only one set, which type of sets we found them. Now here two sets given, so whether they are equal sets or a equivalent set. Earlier we discussed equal means number of elements need to be same and elements also need to be same. Equivalent means if number of elements are same, they called as equivalent sets. So see, first set, what is the first set? X is a multiple of 10, multiple of 10 less than 100. So 10 multiples less than 100, 10, 20, 30, 40, 50, 60, 70, 80, 90. 100 is not less than 100 is equals to 100. So next B1, 5 is a multiple of 5 less than 50. So multiples of 5, 5, 10, 15, 20, 25, 30, 35, 40, 45. So 50 is not less than, 50 is equals to. So how many elements are there in set A and set B? Number of elements in set A, 1, 2, 3, 4, 5, 6, 7, 8, 9. Number of elements in set A 9, and number of elements in set B 1, 2, 3, 4, 5, 6, 7, 8, 9. So number of elements in A equal to number of elements in B. Both of the sets having same number of elements. If the number of elements are same, the two sets are said to be. Here elements are not same. First one having 10, second one also having 10, but not all the elements same. Equal means all the elements also need to be same. So this kind of set is called as equivalent set. Equivalent set, only number of elements same, elements are not same. Next B1, E is a set even natural number, O is a set odd natural number. So number of elements in E infinite. Why? Because even numbers, natural even numbers uncountable, natural odd numbers also uncountable. Number of E is equals to number of O, both of them infinite. That's why these two sets also equivalent sets only. Uncountable elements are there, that's why both of them having uncountable, that's why same number of elements. Now C pair. In the C pair, A is the set letters of the word at least. So what are those letters in at least? A, E, no need to write two times any letter. A, E, A, E, A, E, L, A, E, L, S, T. How many letters? A two times came, so that's why one time. E one time, L one time, T two times, one time I wrote, S one time. So in set A, E, L, S, T letters are there. In set B, same. Steel, what are those letters? A, E, L, S, T. To understand, I'm writing them in proper order. So set A having how many English alphabets? 5. Set B having how many alphabets? 5. So same alphabet, same number of alphabets. That's why set A and B are equal sets. Set A and B are equal sets. D problem. A is ovals of English alphabets. Simple. A is ovals of English alphabets. A, E, I, O, U. Next, B is another set. In that set, here one word given, mensuration. But now what he is asking, X is not a consonant used in the word mensuration. So leave that consonants and write down the remaining letters. So M, leave that. So A is there. A is not a consonant. Mensuration. A, E, I, O, U. A is there, E is there, I is there, O is there, U is there. So these letters only, not consonants. So it means A, E, I, O, U are there in first set, A, E, I, O, U are there second set. So number of elements in set A 5, number of elements in set B 5. So set A and B having same elements A, E, I, O, U and same number of elements 5. N of A is equals to N of B is equals to 5. So which type of sets? Equal sets. Next E problem. X is a negative integer, Y X is a positive integer. So elements in number of elements in X set infinite. Because negative integers, infinite integers are there. Positive integers, infinite positive integers are there. So n of X and n of Y having infinite number of elements. So that's why those infinite elements are not same. Why? Because these are positive negative integers, these are positive integers, not same, but both of them infinite. That's why these two are equivalent set. These two are equivalent sets.